In this example, we're given the function f of x equals -4 square root of x minus 1. Okay, so the instructions first ask us to list the transformations that have occurred in the parent function of this graph to result in this new function. So first we want to identify our parent function. So if you cover up all the numbers, cover up the -1, cover up the -4, you're left with a square root of x. So that's our parent function. Okay. So I like to look outside the grouping symbol first for our vertical changes. And if we look outside the grouping symbol, we've got a -4. Now, we actually want to look at that -4 as a -1 times a 4, which we obviously know is -4, but we want to separate those out because if you recall, multiplying by a -1 outside the grouping symbol causes a reflection, a vertical reflection, about the x-axis. And then, when we're multiplying by 4, that number greater than 1, outside the grouping symbol, that's going to cause a vertical stretch by a factor of 4. So we're going to list these transformations. So we've got our vertical reflection about the x-axis, that's from the -1, and we have our vertical stretch by a factor of 4 from that 4 that's being multiplied. So those are our vertical changes. That's all that's going on outside the radical. Now inside the radical, inside the grouping symbol, we're subtracting 1. Remember, horizontal stuff tends to be backwards, so if we're subtracting 1, we're actually going to shift to the right 1 unit. So our third transformation is a horizontal shift right 1 unit. Okay, so there are our transformations. Now we actually want to perform these and use transformations to graph. So remember, when the directions say that, it means specifically all the work we're about to show. I cannot stress that enough. That's super important to show exactly the way I'm about to show you this, the way we did in the other example as well, so that you get full credit on your quizzes and tests. Okay, so we're going to make a table. We'll start with our parent function, square root of x, in one column, and then our new function, -4 radical x minus 1, in our second column. So we want to start with 3 key points on our parent function. And again, key points are not points you have to memorize, but you want to be able to easily generate 3 points on the graph to give you the basic shape of this function. So if possible, -1, 0, and 1 are easy points to plug in. But we should recall, if we put a negative in here for the x, we'd be taking square root of a negative, and that would give us a non-real number. So this function's actually not defined for -1. So we can't use -1 here. So we'll start with 0. So if I take the square root of 0, I know I'm going to get 0. So I've got 1 point. 1 is good. 1 works. That's an easy one. If I put in a 1 for x, the square root of 1 is 1. And then you just need another third point. Doesn't really matter. A nice one to plug in would be a perfect square. So our next perfect square would be 4. So if we put the 4 in there, the square root of 4 will give us 2. So those are 3 nice easy points that will give us that general shape. Okay, so now we want to perform the transformations to this parent function. So we look up at our list of transformations. The first was that vertical reflection about the x-axis. So if you remember, that vertical reflection happened because of this -1 on the outside. The vertical stretch happened because of the 4. Well, really, -1 times 4 is just -4. So we can combine and perform both of these transformations by multiplying the y values. Multiply y values. Y values because it's vertical. Multiply y values by -4. And that will perform those 2 transformations. So those are my vertical changes. So I'm going to apply those vertical changes to my y values in these key points. So I've got my new ordered pairs. So I'll take my y value of 0 and multiply by -4, and that stays 0. And I'll take my y value of 1 and multiply by -4, and that's -4. And then my y value of 2, multiply that by -4, and I have -8. Okay, so now we've got our horizontal change, our horizontal shift, right 1 unit, and we know that occurred because of the subtraction inside the grouping symbol, but remember, horizontal stuff's backwards, so to shift it right, we're actually going to add 1 to our x values. So we're going to add 1 to our x values. So I take my x value of 0, add 1, and I've got 1. Take my x value of 1, add 1, and I get 2. And then take my x value of 4, add 1, and I get 5. So now I can plot these 3 new points on my new graph. 1, 0, 1, 0. Make sure they're labeled. I'll remind you on quizzes and tests. 2, negative 4. 1, 2, 3, 4. And then 5, 6, negative 8. And then we know that the general shape, the shape of a square root function, is that increasing ray or sun ray or ramp. My students have called it a ramp shape. So we connect the way we know that that graph's going to go. So we know that a parent square root function starts at 0, 0. So when we transformed it, that quote-unquote starting point is now going to become that 1, 0, and then it's going to be that ray shape. So if you look at your transformations, you can see the vertical reflection. You can see that it used the parent function is that ray, an increasing ray. Now that ray or ramp shape has been reflected down here. You can see it's a little narrow or it's stretched, and you can see the shift to the right. And if it helps you, you don't have to do this, but if it helps you to graph the parent function 0, 0, 1, 1, 4, 2, if that helps you, you are certainly welcome to do that. So this was our original square root of x. And then after those transformations, here's our negative 4 square root x minus 1. So remember, what I'll be grading is this. This is the most important part of all this work, because we have graphing calculators that could give us the graph. It's almost like the graph isn't what's important, it's how you got to it. And it's through transformations right here. So I'll be grading this, and then your labeled final graph. And you don't have to graph the parent function, but you certainly can.